Live from the central coast of California, this is NASA's launch coverage of Landsat 9. In just about 40 minutes, this Atlas V rocket will launch Landsat 9 into space to show us Earth from above and help us take better care of our home planet. The Earth observation satellite will add to a decades-long portfolio of data on our forests, farms, cities, and water. Welcome and thank you for joining us here at Vandenberg Space Force Base on the central coast of California for the 2000th launch from this military base since 1958. I'm your host, Marie Lewis, socially distanced and fully vaccinated against COVID-19. That is why I am not wearing a mask. Launch is set for 11:12 this morning Pacific time, and that puts us at L-40 minutes, 20 seconds and counting. The first Landsat satellite launched in 1972, kicking off an uninterrupted stream of data for almost 50 years, and Landsat 9 will continue that streak today. Right now, we are go for launch, but we'll get an update from Launch Control in just a minute. First, some key things to know about today's mission. At least one Landsat satellite has been in orbit continuously since 1972. The program holds the record for the longest continuous observation of Earth from space. The satellite monitors natural and economic resources from orbit. Leaders around the world use Landsat data to understand climate change, manage agriculture, allocate water resources, and respond to natural disasters. And the entire Landsat archive is free and open to the public. Landsat is a joint mission between NASA and the U.S. Geological Survey, and we'll talk to a representative of the USGS in just a little bit. We'll also tell you about a woman known as the mother of Landsat and how her work changed the way we see Earth. We'll show you how the satellite works, turning light into data for scientists and researchers. We'll take a closer look at how the data is used, from mapping the shrinking rainforest to glacial recession to managing our food supply and measuring the impact of natural disasters, which have been particularly devastating in recent days. So we've got a ton of science to get to, and NASA Edge's Blair Allen and Franklin Fitzgerald are standing by. Hi, guys. They're going to help us with some of that science. And also NASA's Daryl Nail and Mick Woltman, who you see in the masks inside Mission Control. They are there monitoring the countdown. And, guys, we're going to go over to you to see how it's going. Daryl and Mick?
Yeah, welcome into the Mission Director Center, Marie, where behind me you can see the big screens of everything that's happening. We have the top leadership of NASA here, along with USGS and the Secretary of the Interior, along with other special guests. As you mentioned, we are now L-38 minutes and counting until launch at 11:12 a.m. Pacific time, 2:12 p.m. Eastern time, and we've got a 29-minute window. So far, things have been going pretty good, but Mick, it's been reported, it's out on social media, there was a little issue that they were working.
Yeah, the team was performing cryogenic tanking, and during that tanking, what we call our fast fill sequence, the team had to work through some issues with the valve. They were able to resolve that, get out of fast fill and into slow fill, or what we refer to as topping now for cryogenics, and everything is back on track. We're running roughly about 5 to 6 minutes behind for one of ours, but that is exactly why we're in this coming up hold. We'll be able to use some of that hold time to finish up that work.
Let's talk about that hold, because that's a good time to go ahead and mention that, right? We are just minutes away from going into an L-34 hold, and the T clock and the L clock will be a little different. Can you explain that?
Yeah, absolutely, Daryl. The L clock is what we refer to as time to launch. This clock continues to count throughout all the operations, and it includes the built-in hold times that we talked about, the T-4 hold being 30 minutes. The T clock is what we refer to as the terminal clock, which tells the team to prepare their tasks at certain times, keep things going. But this clock does stop during those 30-minute holds. Both clocks will sync up at L- and T- 4 minutes, where everything then starts happening pretty fast by the team, and we get down to T0 or liftoff this morning.
And for the purposes of our audience and our broadcast, you will see that L clock in the upper left-hand part of your screen, currently counting down at 36 minutes and counting. We will have that for you. That will go all the way down to 0, a convenient way to see that. Also, our mission milestones we've got listed across the bottom of the screen. We will then make our way and progress through each of those milestones, some of the big ones, the polling, liftoff, of course, booster cutoff, and Centaur cutoff. A look out at the pad, and you can see Atlas V is stacked and ready to go. Landsat 9 at the very top. Today, Mick, this is flying in the 401 configuration. Explain that for me real quick.
Yeah, Daryl, the 401 configuration is the most common configuration flown by United Launch Alliance. It first flew in August of 2002. And the 401, what that designates is the size of the payload fairing that's used. It also the number of solid rocket boosters that are required for the mission, or what mission extra boost that is needed. And then the last number being the number of Centaur or second stage engines that are needed for the mission today. So for Landsat 9, we are flying the 401, which is a 4-meter fairing, 0 solids, and 1 RL-10 engine to get us to space.
And as you look outside and see that view, it might look like the weather is bad. In fact, there are clouds, there is marine layer, and there's some fog, with even a little bit of smoke coming in from the Sequoia National Forest, a fire there burning about 150 miles northwest of us, but that is not expected to impact launch. We are 90% go with weather. We'll talk more about that in a bit. For now, we'll send it back to Marie.
All right, thanks, Daryl and Mick. We are now at L- 34 minutes, 59 seconds and counting. And Landsat 9 will collect the highest quality data ever recorded by a Landsat satellite. These new measurements can be compared to older ones to paint a picture of how our Earth is changing. Take a look.
Soaring high above our home planet, Landsat 9 will provide critical data on how Earth is changing. Circling the globe every 99 minutes, 14 orbits a day, continuing decades of observations. The impact of the Landsat record is the sheer amount of information we've collected all across the world since 1972. And it is high-quality science caliber data, enabling us to accurately track changes over time. Now, 50 years of Las Vegas expanding may be fairly simple to notice, but we can also observe short-term changes, like the growth of farm crops through a season in south-central Kansas. With more than one Landsat satellite in orbit, plus the European Sentinel-2 satellites, we will get data several times each week, improving our ability to track crop health and more. The temperature measurements from Landsat 9 will be used to calculate how much water was used by each farm field. The Central Platte Natural Resources District, like many throughout the western United States, relies on Landsat data to manage irrigation and increase water efficiency. Landsat 9 will also improve monitoring of coastal waters. The increased precision in data sent back from Landsat 9 will allow finer distinctions in the levels of light reflected from water, making it easier to identify any pollutants that are present. Around the globe, growing population and expanding development result in higher amounts of runoff, damaging sensitive nearshore ecosystems. Landsat's long history lets us look into the past to see the effects of land use changes. The consequences of climate change can also be seen in Landsat's long data record. Scientists have used Landsat to track shrinking glaciers for decades, and Landsat 9 will continue that effort. The glaciers in the Himalayas are a key water source for billions of people in South Asia. Due to global warming, the increased meltwater collects in large lakes at high altitudes and poses a flooding risk to downstream villages. Landsat data is essential to monitor the growth of these lakes. Because of their location, glaciers are not easy to study in person, but Landsat's view from space allows us to study glaciers all around the globe. Landsat 9's improvements will make it easier to see features on the glacier surface. With that, we can better track how fast the glacier is moving. Knowing the velocity of the ice now and how it has changed over the past decades, helps us forecast likely contributions to rising sea levels in a changing climate. Landsat 9 joins Landsat 8 to continue the unbroken string of Landsat data. For 5 decades, we have relied on Landsat's high-caliber, science-quality observations to understand and protect our home planet. And while Landsat 9 begins sending back data, we are already planning for the next evolution in the Landsat program.
Now that we've seen what Landsat 9 will do, let's take a closer look at the spacecraft itself. Landsat 9 is 15 feet tall, 10 feet deep, and 10 feet long. Once in orbit, it will deploy a 32-foot-long solar panel and 4-foot-long Earth shield. With fuel, it weighs almost 7,200 pounds. The satellite has 2 main instruments, Operational Land Imager 2 for reflective band data and Thermal Infrared Sensor 2 for thermal infrared bands. It will capture 700 photos each day and travel nearly 17,000 miles per hour. All right, we have a very special guest joining us who you may recognize from the movie Kong, Skull Island. Actor Mark Evan Jackson, thank you so much for joining us, also known as Landsat Steve.
In that film, I was known as Landsat
Yes,
Steve.
and you have the jacket on, too.
I do. I have a bona fide screen-used prop, screen-used piece of wardrobe.
Love it. So in the movie, you played a Landsat researcher surveying a fictional Skull Island. Vandenberg looks spectacularly like that fictional Skull Island this morning.
Yes.
We might see Kong coming out of the distance.
We should all be very vigilant. Anything could happen.
So you actually got a chance to see the rocket up close yesterday. Tell us about that.
It's stunning. I mean, it's legitimately breathtaking and a really special opportunity to think about being so close to something that, you know, within a day is going to be headed for space, and within the fairing, something that's going to live on for, you know, many years, gathering data as an Earth observation satellite. The full culmination of what it means, you know, to be at this stage of the game ready to launch is so remarkable. The science and the engineering and the creativity and the curiosity and the ambition and collaboration that leads to this day is, I mean, it's legitimately inspiring.
How much did you know, if anything, about Landsat before you played the character Landsat Steve, and how does that compare to what you know about the program now?
I'm embarrassed to admit that I was completely unaware of Landsat as an entity prior to getting this role in the film, but immediately began looking into what it meant to be Landsat and to be a Landsat scientist. And Hollywood does a very good job of doing their research. Some of our hand props I've shown to some actual Landsat scientists, and they are very bewildered to go, like, a lot of this is right. Like, a lot of this is accurate. Now I'm fascinated by the goings-on at Landsat. Like, it's so remarkable to think about the nearly 50 years of continuous observation and data gathering, and also that all of Landsat's data is available and free to the public and to industry, and people are able to access it and use it to see how our planet is sadly changing.
Of course. Now, you're going to be watching launch just feet from where we're sitting over here. Hopefully, this marine layer will clear out enough so that we're starting to see the launch pad. It's a little better than it was a couple hours ago.
I feel very good about it. Yeah, I think things are heading in a good direction.
All right. Well, Mark Evan Jackson, thank you so much for joining us. We hope you enjoyed the launch today.
Thank you very much.
All right, let's go over to Daryl and Mick now for a check of the launch weather forecast. Daryl?
All right, thank you, Marie, and good to see that Landsat Steve's doing much better. Since we last saw him on Kong Skull Island, he was getting flattened.
Yeah, he looks a lot better than he did in that final scene. So
Sure does.
Glad to have him here today.
Yeah, he was Land Flat Steve after that movie, so now he's back to his normal self. Good to see. Great interview. Thanks for that. The weather briefing just happened. We just got some news that is great. Of course, the 90% go is still on. Our launch weather officer, Addison Nichols, saying that essentially we are looking great, even though when you look outside, it doesn't look all that fantastic. Our progress bar showing that we are at the weather briefing, and we just had it. Take a look at the satellite. We can show you a couple things that are in play here. 2 weather features along the central coast. Right to the left, there's a upper level low that's squeezing. To the right, a monsoonal low. And so in between, we've got some calm winds and a thick marine layer. Those don't affect launch. So right at T0, we're 90% go. Very small concern for surface winds. And again, just a minor factor, Mick.
Yeah, absolutely, Daryl. These weather looks great here for us in Vandenberg today, so glad to see weather's cooperating with us.
Unfortunately, the 30th Space Launch Delta forecast deteriorates significantly tomorrow, which is the backup day, because as you can see in this loop, that cold front will play bigger tomorrow than it does today. And in fact, it's only a 40% go, because ground winds will be gusting up to 24 knots. You can see in the upper left-hand part of your screen that upper level low. It will drop down and winds will increase. And that will put us in a situation where we don't want to be, Mick.
Yeah, absolutely. Those winds will be bad for us for the launch vehicle design and launch liftoff and control of the vehicle. So let's hope we get off today.
So we hope that that will happen. And looking back out to the pad, you can see there's some fog. There's even some smoke from nearby fires, making a little bit of a haze, but we are go for launch. We'll send it back. Actually, we'll talk a little bit about LSP in a future segment, but for now, let's go back to Marie.
All right, thanks, guys. We are at L minus 25 minutes, 46 seconds and counting until liftoff of the 9th Earth observation satellite. And as we mentioned, this program dates back almost half a century. Here's an animation we're about to show you of the timeline of the Landsat program, starting with Landsat 1. It launched back in 1972, and it takes us all the way through Landsat 9, of course, launching today. The hashed lines for Landsat 7 through 9 indicate the uncertain lifespan of the satellites. Landsat 6 failed to reach orbit after launch. Still, it's hard to overstate the value of the Landsat archive of the past 49 years. One more history lesson before our next guest. Take a look at a photo we have from 1971 inside the Launch Control Center at Kennedy Space Center. There it is over on the Florida coast. This was when Apollo 15 was preparing to launch. And the man on the far right is Dr. James Fletcher. He was the NASA administrator at the time. And as administrator, he would go on to predict that if there were one space-age development that would save the world, it would be Landsat.
50 years ago, the U.S. Geological Survey had an idea. Satellites orbiting Earth that could help us monitor our natural resources. Today, the Landsat program is jointly managed by NASA and the USGS, providing an unparalleled record of Earth's changing landscapes for the benefit of all. 50 years of satellites. 50 years of life-changing data. One legacy continued with Landsat 9.
We have a special guest standing by now with NASA Edge's Blair Allen just outside Mission Control. Blair?
Thanks so much, Marie. Joining us now is a very, very special guest, the first Native American to serve as a United States Secretary of the Interior and as in a cabinet-level post, Deb Haaland. Secretary Haaland, thanks so much for joining the show this morning.
I'm thrilled to be here. Thanks for having me.
When we think of Landsat, Landsat's shown us a lot of interesting things, how we're impacted by drought, hurricanes, even man-induced activities like urban development and deforestation. How does this kind of data help the average person?
Well, I'll tell you what, those of us in the Department of the Interior and the government-wide, we're making policies every day to make sure that we can keep our environment safe and clean for generations to come. And hard data like this helps us incredibly. But also, look, we have opportunities to see those changes over time. The Landsat's been in existence for the last 50 years. The technology gets better and better each time. And so this is such a rich form of data that we can use that will help people's everyday lives. They may not know that, but there's folks working behind the scenes every single day to make sure that people can have what they need moving into the future.
Well, it's interesting because I was going to segue right into how this impacts policy, but you jumped there right away. So in your experience so far, have you worked with lawmakers to sort of chart some policies that would actually be helpful in regards to climate change?
Absolutely. And of course, we're in the thick of the climate crisis right now. We see that every day. Drought, wildfires, hurricanes. Hurricane Ida that devastated parts of the South and went all the way up to New England. I mean, images like the ones that Landsat 9 will bring back to us will help us tremendously to guide us in how we are approaching climate change, working to make sure that we can make the best decisions possible so that folks have water into the future, that we can grow our food into the future. These are all things that will affect the daily lives of every single American, and quite frankly, these are pictures from around the world, not just the United States. So it's going to help folks all over the world to make those decisions, and it's unmistakable, incredible, hard data that we can use every day.
Absolutely. Thank you so much, Secretary Holland, for being on the show. Back to you, Daryl.
We are now L-20 minutes and counting until launch, and we've been monitoring the launch teams with our headsets. We're plugged in, and Mick, you just got some good news.
Yeah, we did. We got to hear from the launch team that everything is go. They're back on schedule. Things are working well, and we are green for our 11-12 launch opportunity this morning. So that's exciting that we're getting ready to launch Landsat 9.
That's great news. We've got a little moisture on the camera, as you can see there. There's a little mist in the air. There's some fog, and there's a marine layer, but none of it is expected to stop this opportunity today. Mick, want to talk about the launch time at 11:12 a.m. Pacific time. That actually moved 1 minute. What was the reason for that?
Yeah, Daryl, we moved the 1 minute to 11:12 this morning in order to accommodate a COLA, or what we call a collision on launch assessment. For the C-Train, the C-Train is made up of two satellites, Calypso and CloudSat, that LSP launched back in 2006. And we want to make sure that when we launch Landsat 9 this morning, we get it in that near-polar sun-synchronous orbit, but we don't want to hit our fellow satellites that are Earth observing. So to avoid that, we made sure that Landsat 9 needed where it go. We moved the launch by 1 minute in order to avoid the CloudSat satellite.
Got to have room in space to get to space, and so we are looking good from that aspect as well. As we look at a shot here from the pad, you can see the steam that's coming off the rocket. Those are just vent valves, right, that are venting off excess liquid oxygen.
Yes, Daryl. Actually, as the team is finished up, we're in what we call topping mode. And as the liquid oxygen, liquid hydrogen boils off, that's what you see coming off there. And as we get ready to go into T-4 and counting, you will see those vent valves close, and that will stop and bring us to flight pressures.
Now, as you look at that rocket, there's actually a special dedication on it. You can't see it, but we're going to show it to you in a second. There's a special dedication there, and the reason is it's because of this man, Thomas Heater II. Heater began his 45-year career in the launch business at General Dynamics and relocated here to Vandenberg as a flight test engineer in the mid-60s. He rose to director of Vandenberg launch operations, and during that time supported 200 Atlas, Titan, and Athena launches. Heater II passed away several years ago, and so ULA put this special dedication to him on the side of the Atlas V rocket, and you can see it there in memory of our colleague and friend, Tom Heater II. His family and friends gathered around the rocket as well and took a photo. And Mick, you had the privilege of working under Heater II, and may I just point out, between the U and the A, right there on the L, is Thomas Heater II's son, the third.
Yes, Daryl. Mr. Heater was a remarkable leader, humble person, and you know what? I had the privilege of working with him on many Atlas missions here at Vandenberg Space Force Base before I started with NASA. Mr. Heater was the director of launch operations at Space Launch Complex 3, but what I remember the most is he would always keep an eye on things going on at the pad, but he always took care of his people and looked out for things. And as you said, special note for us in Launch Services Program, we get to work with his son, who is today's launch director, who we will hear from later, and he's a remarkable person also. Well, great dedication to the Heater family.
Indeed, and we'll hear him report out as the last in the L-7 poll. We'll get to that in a bit. But first, I want to talk about LSP and their ability to bring together the rocket and the spacecraft.
Since the dawn of humanity, we have looked to the stars and dreamed of bridging the gap between the Earth and the cosmos. In the 20th century, NASA turned that dream into a reality by launching humanity into a bold era of scientific discovery. As pioneers of space travel, our best and brightest designed and built everything from the ground up, from launch pads to rockets, all of which were government-owned and operated. As NASA's science and robotics evolved, we encouraged a competitive launch market to develop, ushering in a new way to explore and discover through commercial spaceflight. Spacecraft customers from around the world, all with the same desire, reached out to find an expert at NASA for support. Thus, NASA's Launch Services Program was born. Our mission is to centralize NASA's launch services and address state-of-the-art customer needs when placing their spacecraft in orbit around the Earth, the Sun, or destinations deeper into the solar system. The LSP family is made up of a diverse tapestry of government and contractor engineers, analysts, operation experts, and business advisors, all united by a common goal: to get your spacecraft off the ground on time, on budget, and successfully to its final destination, wherever that may be. We match scientific and robotic spacecraft with the appropriate rocket and certify rocket performance and reliability. We support full-service missions, advisory services, and one-of-a-kind contracts. The Launch Services Program is the common thread that bridges the spacecraft organization to the rocket designer, and the spacecraft to the rocket. We provide long-term technical leadership and expertise from pre-mission planning to system verification and validation, all the way through launch. Whatever the vision or requirements, our team will be there, guiding our customers every step of the way on their journey through space. We are the common thread that connects the science world to the physical world by putting the necessary instruments in place. The thread that weaves NASA's industry-leading knowledge and support into the fabric of the commercial space market. We unite customers, capabilities, and culture to explore space through unparalleled launch services. NASA's Launch Services Program. We are Earth's bridge to space.
It is L-minus 14 minutes and counting until liftoff. We've talked a lot about the history of Landsat, but we would be remiss if we did not point out the mother of Landsat, the woman who created and fought for it. Virginia Norwood was an MIT graduate and physicist working at Hughes Aircraft Company in the 1960s, and she knew NASA wanted a way to capture multispectral images from space. She set out to solve the problem, and through years of research, development, and testing, she created the multispectral scanner system that flew on the very first Landsat satellite. As a testament to her legacy, there is an entire group of women on Twitter who call themselves the Ladies of Landsat. They draw inspiration from Norwood as they highlight the work of underrepresented researchers, and we will hear from the co-founder of this group a little later after launch. Virginia Norwood could not be with us today, but we do have some of the Ladies of Landsat here at Vandenberg to see the launch up close, and we hope they enjoy it. Joining me now is Dr. Thomas Zurbuchen, Associate Administrator for NASA's Mission Directorate. Thomas, thanks for being here. It's starting to clear up. We can actually see the pad now. Tell us, how does Landsat tie into the entire Science Directorate portfolio?
Marie, what an amazing day. I'm just so excited. And of course, this is the first of 11 launches in Earth science in the next 2-3 years, just from NASA alone. Mm-hmm. And in many ways, the way I think about Landsat, it's really the foundation, the contextual data in which we look at all the Earth science we do, the research that we're doing, looking at our amazing planet. Because of the nearly 50-year time, the way I think about it is almost like a painting. Mm-hmm. Our research is the paint, the Landsat is the canvas. So it really belongs together very deeply.
Absolutely. And Landsat obviously looks down on Earth, surveying the entire planet. Does anything we learn from Landsat help us turn outward to explore further into the solar system.
Absolutely. You know, the work that we're doing in all of NASA, of course, expands beyond Earth science. We have missions that will go to the Trojans, a planetary mission, the James Webb Space Telescope launching later this year, and we use the very same technology that we're using for these analysis of the cosmos of other planets, looking at our planet. So yes, we learn from there to here, but very much we learn from the Earth science instruments to look at how we explore other planets.
Sure. I want to also ask you about this huge treasure trove of data available for researchers. It's available to the public. First, we have a quick video to explain that.
Landsat archives its 9 millionth scene. Each scene is a satellite image from space, about 115 miles wide. Researchers and, well, just about anyone can download scenes from the Landsat archive managed by USGS. Landsat holds the title for the longest continuous space-based record of Earth in existence. That's 50 years of scenes like these, helping scientists and researchers understand how our planet is changing over time.
So we just saw a video there about Landsat having archived 9 million images and counting. We're adding 700 every day to that. Until the earlier 2000s, this data was not free. People had to pay per scene. Now that's completely free. It's available to anyone who wants it. Why is that so significant?
Oh, it's absolutely essential to unleash the power of the data that we have. Of course, our partnership with USGS remains strong. They are our, if you want, translators of really the images to the application spaces in our world, whether it's agriculture, fisheries, and beyond. But by making the imagery public, what happens is that companies, non-for-profit or for-profit companies, can take those data and put their own data on top of it and actually add to the value of the Landsat data in ways that otherwise would not occur. So it's a huge stimulant on entrepreneurial thinking of the type that the US is known for.
And beyond Landsat, we're looking forward to launch in 10 minutes or so. But real quickly, what else are you looking forward to this year for the Science Mission Directorate?
Wow, it's an amazing year. Frankly, there's hardly ever been one like this. Just 2-3 weeks from now, around mid-October, we're going to launch Lucy to the Trojans. They're out there at Jupiter distances, bodies of the solar system we've never observed. The James Webb Space Telescope and 2 missions, one looking at the Violent universe in X-rays, and then the first collision experiment of a spacecraft with a near-Earth object.
All right, Dr. Thomas Zurbuchen, thank you so much for joining us. Enjoy the launch. And with that, let's send it over to Daryl and Mick to take us through these final minutes before liftoff. Guys?
All right, thank you, Marie, and welcome back into the Mission Directors Center. We've been listening to the launch team and just got some great news from NASA launch manager Tim Dunn, who declared that Landsat 9 is now on internal power. That means things are looking really good.
Yeah, Tim Dunn completed his poll with the team, notified them that weather looks good, the range is good, spacecraft is on internal power, like you said, Daryl, and those are all good indications that we are go for launch at 11:12 this morning. So excited to hear about that. The next up, we will hear from United Launch Alliance launch conductor Scott Barney. He will perform at L-7, the ULA teams poll, where we will hear the team give their go, ready to enter terminal count. And as we mentioned earlier, launch director Tom Heater will give that final proceed to launch.
And of course, a dedication going up on the rocket with his name on it. His son, as you mentioned, the launch director, will be listening for that poll, which is coming at L-7 minutes. If you look across the bottom of the screen, you can see we're at weather briefing. Coming up is polling, and we'll hit that at L-7 as we count down. 60 more seconds until that moment. As we look out at the rocket, we see that we've had a little bit of clearing. That doesn't affect the chance for launch. But Mick, it's nice to see that there's a little more visibility, 4 miles visibility, which is exactly the distance between this rocket and our host desk where Marie is in the launch viewing area.
Yeah, I'm feeling a lot better seeing some of that fog clear off, that Marie will be able to actually see something from where she's located. With all the guests she has up there, that's exciting. Like we said, the weather is really cooperating with us this morning, and as this fog here in Vandenberg moves out, weather still remains go, and the United Space Force has assured us that we have a green all the way through launch.
And once they go green and once this thing launches, it will be the 2000th launch from Vandenberg Space Force Base, as well as the 300th Atlas. Let's listen in now as they conduct that poll.
L-minus 7 minutes.
Status check to proceed with terminal count. Atlas systems. Propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems. Propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Has gas.
Go.
Electrical systems. Airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Operation support.
Go.
COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Red line monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
You have permission to launch.
ALC. Verified T0 is set for 1812 Zulu.
Verified.
1812 Zulu, that's UTC time, and we are go. And I got to tell you, it was nice to hear Tom Heater III give that go right there at the end.
Absolutely. I got goosebumps here, Daryl. Every time we get to this point in a launch, it is great to hear the team give their goes. And this is special for me, too, to dedicate this to Mr. Tom Heater II and hear Tom Heater give that proceed to launch. That is so... I can't even explain how I'm feeling right now. I'm so excited for Landsat 9 this morning. Looking forward to this launch.
His family and friends also here present to watch this with all of us. We are now counting down to the T-4 hold, where we're going to get those clocks synced up with the T clock and the L clock. This has kind of been a windy road to get to this point, though, Mick. This launch originally scheduled for September 16th. It moved to the 23rd. There were some issues with liquid nitrogen getting into the pad because of a COVID-19 induced issue with liquid oxygen back in Florida. So it created a shortage here. Moved past that. Also had a little issue with the spacecraft getting it up because of the winds. But Launch Services Program stuck with it, stayed the course, and got us to the launch day today.
Yeah, you know, I'm very proud of the team. NASA's Launch Services Program, our commercial partner, United Launch Alliance, the United States Space Force, they worked hard to get through this. It has been a windy road to get here, but you know, the team's dedicated. This is just part of the rocket business, and these guys have maintained their processes, followed through their procedures, and worked diligently to get us here today, Daryl. So I can't say enough about the teams that have continued to bring us here for Landsat's launch this morning.
As we approach the T-4 minutes, what do we expect to hear?
So we're going to hear them pick up the count.
Time will be T-4 minutes and counting. 3, 2, 1, mark.
So we just heard now the L clock and the T clock will sync up. We are now entering terminal count. At T-3, we will hear the team secure topping and verify that everything's at flight levels. Around 2 minutes and 50 seconds, we will hear that the flight termination system will go to internal power, making sure that all the safety protocols are on the rocket as we launch this morning. And around 2 minutes, we'll hear that the Atlas and Centaur vehicle go internal on battery power, which is a clear signal that we will be launching on time this morning. And then at 1 minute, we will hear the United States Space Force give us a range go or green thumbs up, and we will then proceed into our T0 mark for Landsat 9 this morning.
As you can see there, the rocket against a dreary backdrop with a marine layer and a little bit of fog. It's 93% humidity here along the central coast of California. It's about little less than 60 degrees in the temperature that's outside. None of that is a factor. Over the past few days, we've also seen some smoke from a nearby wildfire at Sequoia National Forest. There you're looking right down the side of the booster, the Atlas V booster, and seeing that condensation coming off that super chilled skin of the rocket.
Yeah, I love that shot, that rocket cam shot. That'll be a great shot as we lift off this morning. And as you said, seeing that super chilled tank as it filled with liquid oxygen and liquid hydrogen on the Centaur tanks this morning, we're just excited about this. And we just heard from the team that they're going to flight levels on the tanks, and so that's a good sign that we are getting ready to close those vent valves and move into what we call step 3 for flight pressures.
Once that rocket lights, that orange fire will certainly change the light and change the mood of many of the folks who are watching this. Certainly on TV, you're going to see all of that. We've got all the cameras focused in, all the angles on this rocket. You can see on the progress bar, we are go for launch. Our next point is liftoff.
Vehicle internal.
So we just heard the call, Daryl, for vehicle internal. That's a good sign. We're going to hear the last poll here to verify everything is go.
Securing Centaur LH2.
Securing Centaur LO2.
There's where they're securing and shutting off the vent valves and the securing the vehicle.
Launch enabled. 137.
FTS armed.
Flight termination system is armed. We are getting closer and closer to that T0 mark, Daryl.
And there's a big moment at T-minus 45 seconds. What do we hear there?
We're going to hear the launch conductor, Scott Barney, verify from the last minute that everybody's ready to go, and we get a green to go for launch.
It's been a lot of work to get to this point, a lot of preparation. Let's listen in.
There we just heard vent valves locked, and as you saw, Daryl, you pointed out earlier that steaming off the vehicle has now stopped. The vent valves are up.
Rock, report range status.
The range is green.
That is a great sign to hear range is green, Daryl, that we are good to go. Coming up on that poll from launch conductor Scott Barney.
40.
Stable at step 3.
$25.
Status check. Go Atlas.
Go Centaur.
Go Landsat 9.
And there it is, the word to launch Landsat 9.
T-minus 10.
9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of an Atlas V rocket and Landsat 9, continuing the legacy of an irreplaceable 50-year record on our ever-changing planet.
Control system response looks good. RD-180 engine operating parameters continue to look good. Vehicle has begun the pitch over maneuver. Body rates look good.
That pitch over maneuver heading it to the south towards Southern California and down to Mexico.
Now passing 40 seconds into flight. Engine operating parameters continue to look good. Pump speeds and injector pressures all within expected ranges.
There's a shot from our tracker cam above the marine layer.
Now 55 seconds into flight. Vehicle is now completing the pitch over maneuver. Body rate responses continue to look good. 3 minutes remaining in the boost phase of flight. Pump speeds and injector pressures on the RD-180 continue to look good. Body rates continuing to look good. And at 1 minute 20 seconds into flight, Atlas is now supersonic, vehicle passing Mach 1.
A critical moment for the rocket.
And vehicle is now passing max Q, maximum dynamic pressure. RD-180 performance continues to look good throughout boost phase. Engine's now throttling down slightly as expected. Engine response looks good.
That throttle down reduces the stress on the 19-story tall vehicle.
At 1 minute 50 seconds into flight, vehicle is now 10.7, correction, 13 miles in altitude, 7.9 miles downrange distance, traveling at 1,500 miles per hour. Now just under 2 minutes remaining in the boost phase of flight. At 2 minutes 18 seconds, the Atlas V vehicle now weighs just 1/2 of its liftoff weight. And vehicle's gone to closed loop guidance. Body rates indicating a slight adjustment can be expected for this phase of flight.
There's a beautiful shot right there, looking back towards the planet. And see the plume from the RD-180.
And the reaction control system on the Centaur is now pressurizing to flight levels. System pressure response looks good.
So the reaction control system on Centaur, they're prepping it.
RD-180 engine operating parameters continue to look good throughout boost phase. Body rates remain stable.
Coming up in 60 seconds, the booster engines will cut off.
Flight. Approximately 1 minute remaining now until booster engine cutoff.
Our tracker shot getting a great...
And now 3 minutes, 15 seconds into flight. Atlas is 48 miles in altitude, 70 miles downrange distance, traveling at 5,600 miles per hour.
Great shot as it goes out over the southern Pacific.
Pump speeds and injector pressures on RD-180 continue to look good throughout boost phase. And the Atlas V is now throttling to maintain a constant 5G acceleration limit. Engine response looks good.
Speed currently 7,700 miles per hour.
Has begun boost phase chill down. Now throttling to maintain a constant 4.6G acceleration limit in preparation for BECO.
This is where the booster engine cuts off and then separates.
And we have BECO booster engine cutoff standing by for stage set. And we have good indication of Atlas Centaur separation. We have pre-start on the RL-10, standing by for ignition.
And there you see the separation.
We have ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good.
Beautiful shot of the booster falling away as you're looking down.
And we have good indication of payload fairing jettison.
And you should see the payload fairing. Sometimes they come around the side.
12 minutes, 11 seconds.
There you see one.
RL-10 performance continues to look good in the early part of this first burn. Now passing 4 minutes, 47 seconds into flight.
So we're in a good point, Mick. Flight is looking good. We're going to monitor the situation here. But what a beautiful launch. What a beautiful flight so far.
5 minutes.
But there's still a lot of work to do.
Yeah, absolutely. A lot of work to go on, but beautiful shot there of the RL-10 engine in space, sending Landsat 9 onto its orbit. A great launch this morning. So excited for this.
We're getting some of that orbital sunrise on the engine bell there, and that's just a neat look as you look back at our planet. All right, Marie, we'll keep track of things in here, but for the meantime, we'll send it back out to you on the hill.
All right, thanks, guys. We did get lucky enough for that marine layer to clear so we could see liftoff from here at the gravel pit. Earlier, I had the opportunity to speak with NASA Administrator Bill Nelson about today's launch. Take a listen. NASA Administrator Bill Nelson, thank you so much for joining us. You have described climate change as an all-hands-on-deck global challenge that requires action now. Tell us, how does the Landsat program help leaders take action now to address climate change?
We best get on the business of doing it right now. And what Landsat does, it is the longest continuous global satellite record of the Earth's surface. And these satellites have documented Earth's changing landscape. It helps farmers, scientists, understand and manage land resources, and all of that is needed to sustain human life. Such things as food and water and forest. And of course, Landsat's long-term record of our home planet allows us to track the changes and the impacts of climate change.
And President Biden's fiscal year 2022 budget requests $24.8 billion for NASA. That's a 6% increase from last year, and also the strongest budget NASA has ever had for science. How do you quantify the value of NASA's science missions?
It is a very strong budget request. The value is immense. And when you're talking about data like this, it's hard data that arms decision makers with the tools they need to make tough decisions about our future. It's exploration on other planets, helping to answer the age-old questions. How did we get there? Are we alone? It's the inspiration of the next generation. That is what this science budget is all about.
And besides Landsat, in what other ways is NASA making it a priority to understand and respond to climate change?
Well, we are doubling our efforts to lead when it comes to climate science. Earlier this summer, we announced a new Earth Systems Observatory. It's going to be 5 great observatories that will look at the land, the oceans, the ice, and the atmosphere, and combine a 3D composite of what is happening very precisely to our atmosphere. That, combined with all of our other existing assets, such as the Landsats, it's going to develop the ability for us to really measure what is happening. And also, we're continuing